Good afternoon, dear students. How are you all? Welcome to one more amazing session from Infinity Lane from Sri Chaitanya, and this is Suresh, Faculty of Chemistry. How are you all, my dear students? Happy to see you all this afternoon. Welcome to NEET STEP UP 2025 program. And in this NEET STEP UP 2025 program, we are running physics, chemistry and biology sessions right from 12 o'clock to evening 6 o'clock on this YouTube platform. And today we are talking about chemical kinetics of the chemistry. Yes, you are all ready. So what is the advantage and the weightage of the chemical kinetics in grade 12 curriculum? In this NEET chemical kinetics, definitely you are expected to get one question minimum, so that this particular chemical kinetics minimum one question and maximum of two questions, so that this particular topic is very important. Ishita, good afternoon, and this particular topic is going to be a sure shot topic for your NEET examination. So there is no obligation like this topic may come, this topic don't come, so like that you don't have any flickering with that. So chemical kinetics is a sure shot topic, so that you can have a very good interaction in this session. We will discuss everything out of this. Today half of the chemical kinetics we will discuss, and tomorrow we will be discussing the next half, and the Saturday we will be having total multiple choice questions that are related to NEET. Are you ready? Hi Annamani and Ishita, good afternoon to you all. Good to see on the board, right? That's good. And so what is, before going for the chemical kinetics, my dear students, I really appreciate those students who are regularly attending the classes with Infinity Learn YouTube channel, and we request, I am fine, thank you. We request you guys, please like and share and subscribe these sessions, and everything in this chart box you can see NEET 2025 improve rank improvement Google form is there, and you can download Infinity Learn Meta app to create your test. You can create your test that you require. That's good. And in this chemical kinetics, we will be talking about the speed of a chemical reaction, the rate, average rate, differential rates, and also order, molecularity and temperature dependence, Arrhenius equation, whatnot, everything we are going to discuss. And definitely you will be expecting minimum of one question and maximum of two questions from this particular chapter. And of course order and molecularity from this particular topic is directly related to organic chemistry as well. So while it will start the class, and before we start the class, so for the formalities, what Infinity Learn is doing right now and what we achieved in 2024 NEET examination, a slide for your motivation and for your benefit. So look at here, there are 4 students presented on this slide who secured very less score in 2023 examination, and they secured very great marks and lot of improvement after studying in Infinity Learn various courses, NEET examination preparation. And only a few 4 are presented here. Not only this, hundreds of students got this improvement like this. And definitely I can say that for your next examination, you will be in these slides. So that much confidently I can say, Infinity Learn NEET examination preparation packages that we offer, they studied. I personally taught them. Aryan, good afternoon. I personally taught them from Infinity Learn to them for their better examination results. Hi Chatterjee, Kalidas Chatterjee, good afternoon. Now let's see here Arshita, and she got only 310 marks in 2023, she got 661. You can see incredible improvement in NEET examination after studying with Infinity Learn. This is a right evidence that you are on the same track. And you can say Akhil Verma, he got 313 and he secured 658. Incredible. There is a race, 345, not only one student, hundreds of students done with Infinity Learn like that. And Himadyuti, she got 310, just 310, and she got 652, and you can see 342 marks increment. And also Satyanarayanan, he got 330, just 330, made 650. You see how much increment is there. So the academic program designed by Infinity Learn by the eminent faculties, you can see these are the eminent faculties who are giving the best teaching experience to you guys, and you will be getting various salient features of the NEET 2025 rank assurance program. दिस नीट रैंक एश्योरेंस प्रोग्राम, इसमें आपको मिलेगा इतना सारा पॉइंट्स आपका सामने है. So 480 plus hours of live classes. There are live classes for you with complete NEET syllabus for all subjects together. And also you can see the downloadable notes are available, and 5,000 plus topic wise recorded videos, and by India's top NEET faculties, and whenever you want, wherever you want, you can just watch those recordings, just click away. Amazing platform, you believe it or not, it is true, and you can just experience it by just clicking the Infinity Learn app, and you can just go for that. And if you are fine, and you can go into that. And chapter wise previous year questions along with video solutions, and weekend test series also there, and rank analysis and paper discussions and full syllabus mock test. That is a key point. That is a key point. Full test mock test. Okay. 24/7 doubt resolution. Kabhi bhi, kahi bhi. And if you have any doubt, you can have the doubt resolved immediate effect. And you have 30 NEET Achiever series printed books just your doorstep में आपको मिलेगा. And parent and meetings are there so that we can discuss and what is your progress, आप क्या करे, कैसे करे, and आपका improvement कैसे बना सकते हैं, सभी भी आपको मिलेगा. And also if you see these statistics presented there, Kalidas 720 out of 720 in the NEET 2024, after having all kinds of court hearing, and there are 9 students who got this excellent result, and below 100 student 45 बच्चा का है, and scored 132 students का 700 plus students का मिल गया. And if you prepare this NEET 2025 rank assurance program, and the experience is going to be awesome, on low, and the batch starts from 3rd August for the NEET dropper. So these sessions are absolutely important, and you are so close to the date for the commencement of the batches, and get ready. And हमारा class में ये फायदा कैसा होगा, and all the self study programs what you are getting just for 7,500 रुपये के लिए. and आपका ये कोर्स कोड इस्तेमाल करो, सुरेश 50, ये डिस्क्रिप्शन बॉक्स में भी है. and if you use the course code सुरेश 50, इससे आपका 20% डिस्काउंट straight away you are going to get it. so इतना सस्ता पैकेज कहीं प्लेटफॉर्म में नहीं है. मान लो you just take the advantage of this and enroll in the course if you like it. And this is a NEET 2025 rank assurance program. Batch starts on 3rd August. Are you there, right? Fine. And without any delay, we shall start chemical kinetics. My dear students, yes, chemical kinetics में हम पढ़ाने वाला क्या? Yes, here Anamani Ishita, Richa Sharma is there, Aryan Kumar, Kalidas Chatterjee. So let's see in this what you are going to learn in this particular session. Nihal is there today. I want to see Nihal. Okay. So what do you learn in today's lesson? Rate of a reaction, and also factors affecting the rate of a reaction, and integrated rate loss, and analysis of first order reaction, and molecularity of elementary reactions, and effect of temperature, rate, and Arrhenius equation and activation energy. Among all, I may just go with this up to here for today's class, and tomorrow's class my agenda is going to be next 3 points. Right? Are you ready to start? What is a chemical kinetics? Right? Okay. So chat box में कोई अटक गए क्या? Okay, right. Let us start. So how the things are going to be now. So the rate of a reaction. So chemical kinetics is a branch of a physical chemistry part. We are going to discuss about the speed of a chemical reactions. Sometimes the chemical reactions are slow reactions, sometimes the chemical reactions are fast reactions, sometimes the chemical reactions are moderate. So based on classification of reactions on the basis of the speed of the rate, speed of a reaction. So the very fast reaction like a precipitation of a silver chloride, when you add sodium chloride to the silver nitrate, it is a clear solution, it is a clear solution. When you add these two, you are going to get silver chloride, a white precipitate, and appearance of this white precipitate is instantaneous. It takes 10 power minus 12 seconds or less than that. So it is what you call it is very fast reactions. These very fast reactions are also called as instantaneous reactions. Instantaneous reactions, and among them one more there, very slow reactions, rusting of iron. How much time it can takes? This takes, my dear students, it is about a month or 2 months or 6 months, like that, है ना? And you can say moderate reactions, these reactions taking place at moderate speeds, and hydrolysis of starch and decomposition of hydrogen peroxide. When hydrogen peroxide decomposes, it takes a minute. It takes an hour. Tashwin, welcome back. Where did you go nowadays? I couldn't see you. So are you fine? How are you doing? My dear student? Tashwin used to be a regular student. Nowadays you are not seen in the sessions regularly. So I think you are busy with your college activities and all. So I am very happy to see you, Tashwin, after a long time. Okay, anyways, the chemical reactions are very fast reactions or maybe very slow reactions or moderate speed reactions or moderate. I am fine, thank you, Tashwin. And so when you talk about the chemical kinetics you can't apply for very fast reactions, and chemical kinetics are not applied for very slow reactions, and chemical kinetics are applied for moderate reactions. Why? Because if you take the speed of the reaction, you can say rate of the reaction, change in concentration upon time taken for this. If you take the time taken for this is very small and the rate is going to be too high, and time taken for it is very large and the rate of the reaction is going to be too small to measure. So that I just want to use this rate constant only for this moderate reactions. है ना? So let us talk about what is a rate and what are the types of rate of the reactions and how we encounter them. Definitely you will be expecting a question from you, right? That's good, very nice. Tashwin, Kalidas Chatterjee, Aryan Kumar, Vanga Namani, yes. So be active in the chat box so that we can have an interaction type of sessions, right? Again, organic chemistry beta we will be discussing in the next week and with a lot of stuff. Are you ready? Ready with organic chemistry for the next week? This week we had already thermodynamics first 3 days, and next 3 days chemical kinetics. That is my plan. For the next week we are planning for the entire organic chemistry for the 11th as well as in 12th in the mix we can do it. Henna? Are you ready? Yes. Now let us talk about rate of a reaction. So what is the rate of a reaction? In this rate of a reaction, in general reaction, मान लो reactant A gives rise to B and the behavior of the concentration of the reactant and the product in the reaction proceeds graphically. I just want to show. As the reaction goes, the concentration is taken on the y-axis along with the time. So as the reaction proceeds, the reactant A is consumed and it is going to be converted into B. So there is a decrease in the concentration of the reactant and there is an increase in the concentration of the product. So in that there is a decrease in the concentration of the reactant like this. Now I just want to say, मान लो एक time t1 में the concentration of the reactant let us say C1, okay, and as time t2 के लिए the concentration of the reactant become C2. So there is a decrease in the concentration of the reactant and there is a time, that is what you call it as delta t, and that is what you call it as delta C or delta A. So the rate of a reaction is going to be average rate, mean to say that is an average rate. So that is the rate with a time interval, that is what you want to say minus del A upon del T, or you can say C2 minus C1 upon T2 minus T1, that is what you call it as an average rate of a reaction. Hope you all understand. Hope you all understand, my dear students. That's good. We can go ahead, and this is an average rate. You can also go for the differential rate. I am going to show you in the next slide, my dear students. Let us see here. In this average rate, you can say as the time proceeds, concentration with the time and reactant concentration is decreased, reactant concentration is decreased, and product concentration is increased. This is the product concentration that is increased. So this is the graph that is showing to you for the decrease in the concentration of the reactant. In the next slide, we are going to see there is an increase in the concentration of the product B, right? Product B. In this scenario, I just want to say, so the rate is going to be plus delta B upon T, so that it is initially at the time T1 it is going to be C2 and the time T2 is going to be C1. There is a increase when this is what you call it average rate. In this average, you are going to see the change in the concentration with a time interval of time. So if you talk about the instantaneous rate, if you talk about the average rate, the rate in a particular interval of time, that is delta t, the average rate of reaction between the time interval t2 minus t1 is given as a delta t, can be determined from the above graph by locating the concentration of A as well as B. You have to point to it, and that is going to be rate average is going to be A2 minus A1 upon T2 minus T1. Based on that, you can see in the NCERT textbook also a couple of questions has been given. You just go through it and you can do the answer with a lot of confidence, my dear students. Okay, so let us see. Similarly, from the plot B, average rate is going to be B2 minus B1 upon T2 minus T1. I just have a doubt why it is a negative and why it is a positive. So does the rate can be a negative? Does the rate can be a negative? Rate never be a negative, but the negative sign indicating here there is a decrease in the concentration of the reactant. So it doesn't mean that the negative value is indicating is not a negative answer. So rate is always a positive quantity. Mind it, this is very important. This is very important. And let us talk about instantaneous rate. Instantaneous rate. When you talk about the rate, concentration and with the time you got the rate here. But when you talk about like a tangent you take, so this is dt and this is going to be dc. So change in the small amount of the concentration with a small interval of time. When time delta t tends to 0, average rate becomes the instantaneous rate. That is very important, and this is given as rate instantaneous is going to be minus dA by dt is equal to plus dB by dt. So the average is a particular interval of time. Instantaneous is at that instant of time how much concentration change is there. So that is what you call it as instantaneous rate, and that is the difference between the average rate and the instantaneous rate. You all can hear me? Anamani, are you there? Right, fine. Aryan Kumar, Kalidas Chatterjee, Tashwin and Ishita. Want to see? Okay. So let's talk about the more details about very important noteworthy points. I just want to give you only for this instantaneous and average rate of reaction. Right, first one. So the above reaction for this instantaneous rate, if A gives rise to B and rate is going to be dA by dt and is equal to dB by dt. So this above reaction is equivalent to the slope of the tangent of the plot of the concentration of A or B at any instant of time. That's what we discussed. This is a tangential line. If you draw it and you are going to get the slope from there, you can get the rate from that slope. Okay, and that is very important. So this is a NEET examination, and NEET examination students focus on more on biology, so little on physics, little on mathematics and chemistry. So you just follow the logic. I am not asking you to just go for the total mathematics textbooks and you go to the physical chemistry. Always focus on a mathematical logic. It doesn't mean the total things you derive it. No, it's not like that, my dear students. Focus here. Now let's talk about the rate of a reaction, instantaneous or it can be average, is always calculated as a positive quantity. Doesn't mean that it is a negative value. So the negative value indicates it is the decrease in the concentration of the reactant, or else the rate of change in the concentration of the reactant will be a negative quantity, since the concentration decreases with time. Also the rate of change in the concentration of the product will be a positive quantity, since the concentration is going to be increased. That's the reason why intentionally I have given negative value and a positive value over there, right? So these are the noteworthy points you need to know about the rate of the reaction. It could be instantaneous rate or it could be average rate. Dear students, hope you are there, right? Come on, say a thumbs up and fire emoji. Jaldi डालो. Tashwin. Okay, चार्ट बॉक्स में कुछ टेक्निकल इश्यू चल रहे हैं, कोई प्रॉब्लम नहीं. Okay, talking about, so the magnitude of the rate in the change in concentration of reactants and the products will be equal in this case as 1 mole of A gives rise to 1 mole of B. That's the reason why rate is given as dA by dt is equal to dB by dt. So in this way, so the rate of a reaction at any temperature depends on concentration of the reactants and sometimes on the concentration of some foreign substances like a catalyst. So catalyst concentration doesn't make a sense being used in this reaction, but catalyst activity, if catalyst is there or not there, does matter. So don't feel that more catalyst is added, reaction और जोर से जाए. This is not the correct way. So if you add more catalyst, the reaction is going to be more faster. That's a wrong concept. So catalyst, if it is there, it accelerates the reaction or it alters the speed of the reaction. So we are going to discuss about the catalyst at the end of the reactions, at the end of the Arrhenius equations. Okay. So let's talk about the representation of the dependence on the rate of reaction with concentration is known as rate law. We are going to discuss after this slide. So the entire chemical kinetics is based on rate law. I am going to tell you that. And so let us talk about in general reaction. For a reaction, m moles of A plus n moles of B gives rise P moles of C and Q moles of D. So how to write the rate expression? It is written as rate is going to be जो भी number यहाँ पे आने दो ये denominator में डालना. So that is going to be minus dA by dt multiplied with 1 by m is equal to minus 1 by Ashik. So now connection is restored. Okay. Anyways, can you confirm? You can able to see me? Tashwin, Aryan, Chatterjee, Kalidas Chatterjee, Anamani. Right. Okay. So let us take an example over here. N2 plus 3H2 gives rise to 2NH3. How to write this expression? This expression can be written as rate is equal to dN2 upon dt is equal to minus 1 by 3 dH2 upon dt is equal to plus 1 by 2 dNH3 by dt. So this is the expression. From this expression what we are going to learn, that's very important thing I want to give you. This magnitude quantity is called as rate of disappearance of nitrogen. As this reaction proceeds, nitrogen is decreased. This is what you call rate of disappearance of nitrogen. And ये चीज वाला है ना, rate of disappearance of hydrogen, ये चीज होगा, ये चीज नहीं होगा. That's the key point. That's the key point, my dear students. So I just want to say this is what you call it as rate of disappearance of hydrogen. Rate of disappearance of hydrogen. And और एक चीज है, and rate of appearance of ammonia का कैसे लिख सकते हैं ये वाला. So 1 by 2 छोड़ना. So that is what you call it as rate of appearance of NH3. And many things you can explore from this particular slide, my dear students. So I just want to say rate of appearance of ammonia should be equal to, you take these two and you can write 2 into rate of disappearance of nitrogen. Like that. Fine. Or you can also say 2 into dN2 upon dt. And you can also say, rate of appearance of nitrogen can also be said that 2 can be written 2 by 3 into rate of disappearance of hydrogen. So you can say 2 by 3 dH2 by dt. So this is a simple thing you just take into the account. Otherwise, what students do, the entire quantity is taken which is not correct. So based on this also, NCERT a type of questions, 2 questions are there, you just solve it. That you can do the best, right? Why not? We'll go into the details about the various parameters. Okay. So let us do a classroom example based on this. The rate of formation of NO in the reaction NOBr gives rise to NO plus Br2 is found to be 1.6 into 10 power minus 4 mole per liter per second. And find the rate of overall reaction and the rate of consumption of NOBr. So this is the best example that I can give you, where you can see we have dNO upon dt is equal to 1.6 into 10 power minus 4, and from there the rate of overall reaction is going to be minus 1 by 2 dNOBr upon dt is equal to plus 1 by 2 dNO upon dt and is equal to dBr2 by dt, this is by dt, and is equal to 0.8 into 10 power minus 4. And you are going to see the rate of consumption of NOBr is equal to minus 1.6 into 10 power minus 4. It is a simple way to answer. And also units for the rate, units of rate law. So units for the rate law, you can say rate A gives rise to B. So the rate is going to be dA by dt. Concentration of A is mole liter inverse upon it is going to be seconds or time. So you can say mole liter inverse time inverse. Is that fine? Is that fine? So you can say mole liter inverse second inverse. If the reactant is a gas, you can use ATM as an active mass. It is there from the law of mass action. So Infinity Learn, it is Google Forms are there, and you have given the app download link. You all click on this link and you can get all the improvement programs with you on this YouTube platform. Tashwin, is that fine? Yes, it is. Okay, go ahead and let us rise together. Now let us talk about factors that influence the rate of a reaction. Many factors are there, and I just want to talk about 3 factors as of now. First of all, concentration of the reactants and the nature of the reactants. Nature of the reactants, during a chemical reaction, old bonds has to be broken and new bonds has to be established. When the old bonds are broken, a chemical reaction which less bonds are involved are going to be a faster reaction. Of course, ionic reactions in the solutions are faster than covalent reactions, and also you can say as far as the chemical kinetics concerned, physical aspect is part, concentration of the reactant or the product, only you have to consider the reactants, not the product. Pressure in the cases of gases, I just want to say active mass of the reactant. Okay, so you can improve your score in NEET 2025 by just filling the Google form link, so that you will be getting all kinds of analytics and updates about the sessions. And you please like and share and subscribe these YouTube lectures, so that you will be getting benefited and your friends also getting benefited. Henna madam? Yes, that's good. Let's talk here more. The temperature also plays a crucial important. As the reaction goes on, the reactant molecules make a collision, so they collide with certain amount of energy, so they have kinetic energy. As a kinetic energy is directly proportional to absolute temperature. Temperature बढ़ गया तो kinetic energy बढ़ गया, collisions बढ़ गया, rate of the reactions बढ़ गया, है ना? And the catalyst. So if you use a catalyst, the rate of a reaction is increased, because a catalyst takes an alternative path for the chemical reaction. So where the activation energy is less, so it takes the reaction so faster, right? And let's talk about the rate law. Rate law. So the rate law, It is all about, let us consider general equation like this. So A moles of A combines with B moles of B and gives rise C moles of C and D moles of D, where you can see the rate expression for this reaction is given by, so according to law of mass action, so आपका law of mass action जो है ये सिर्फ बैलेंस्ड केमिकल रिएक्शन का हिसाब से देता है. सो द रेट ऑफ द रिएक्शन ये बोल सकते हैं a टू दी पावर a एंड b टू दी पावर b, लेकिन लॉ ऑफ मास रेट लॉ के हिसाब से the rate of the reaction is directly proportional to a to the power x and b to the power y. अरे x ए स्मॉल a के बराबर हो सकते हैं, नहीं हो सकते, ये y b का बराबर हो सकते हैं, नहीं हो सकते, लेकिन x and y are experimentally determined values whereas a and b are balanced equation का numbers हैं. So in chemical kinetics you all have to follow this, and we don't follow this because this is experimental. This is experimental beta, and here it is going to be where exponents x and y may or may not be equal to the stoichiometric coefficients that are a and b in the reactants, and this is what you call it as rate law. This is what you call it as rate law. Okay, rate law कहाँ से निकालना है? एक्सपेरिमेंट के हिसाब से निकालना बेटा. And I just want to say rate is going to be ये e proportional का equation a constant बना के equal बन गया. So that k is what you call it as a specific rate constant or rate constant. In the above reaction is known as rate law expression, and k is known as proportionality constant called rate constant, or also called as a specific rate constant. This is also called as a specific rate constant. Now I just want to say ये specific rate constant ये value देख के हम बना सकते हैं ये reaction इतना speed चल रहा है. So as the speed of the chemical reaction increases, the value of the k increases. That's a very important point. Okay, that's a very important point. And also you can say the rate law expression is in which the reaction rate is given in terms of molar concentration of the reactants, and each term is raised to some power which may or may not be same as a stoichiometric quotient, and in a balanced chemical equation. And also it is very important, the rate law for any chemical reaction cannot be predicted by merely by looking at a balanced chemical equation. Mind it, हर बच्चा ये पॉइंट भूल के एक गलत आंसर पकड़ते हैं, so which is absolutely not appreciated. So example 2, NO plus O2 gives rise to NO2. The rate expression is given as K NO2 square dot O2, but here CHCl3Cl2 gives rise to CCl4 when it's Cl. The rate expression is given as rate is equal to K CHCl3 and Cl2 to the power 1 by 2, because here 1 था लेकिन 1 by 2 कहाँ से आ रहे हैं? एक्सपेरिमेंट से आ रहे हैं. अंडरस्टैंड, दैट्स वेरी इंपॉर्टेंट पॉइंट. सो दैट्स वेरी इंपॉर्टेंट पॉइंट है ना. एंड ऑल्सो लेट अस गो इनटू द ऑर्डर ऑफ ए रिएक्शन. इट्स वेरी 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 सिंपल. ये रेट लॉ से निकालना है. ओके, सो लेट अस से ये गिव्स राइज a plus b gives rise c plus d. So the rate is going to be a to the power x and b to the power y. The exponents जो exponents है x and y, the sum of these x and y gives the overall order of the reaction. X is the order, x is the order with respect to a, and Y is the order with respect to B. So, X plus Y is equal to overall order. Overall order. Samjhe? And the order tells us the concentration depends on the rate of the reaction, my dear students. Okay. So, this is the way you need to follow fundamentally to learn the chemical kinetics, my dear students. So, if you have a question from this particular chapter, you will be having a question either from order or calculation of order. Yes, रेहान राजपुत्रा, अंकुश महाजन, इसका प्रोडक्ट सेम है क्या? ना 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 ना, प्रोडक्ट सेम नहीं होता. Yes. Now, if you attempt any question, maximum questions from this particular chapter, you will be getting calculations based on order, and also another parameter you can say based on Arrhenius equations, you will be having a numerical. So, this is somehow logic and as well as formula oriented. Rehan, fine. Ankush, Mahajan, Tashwin, okay. So, let us talk here. So, hence the sum of the powers of the concentration of the reactants in the rate law expression is called as order of a chemical reaction. So, in this अगर reactant 2 से ज़्यादा हो, so it will be maximum of 3. If it is not 3, you have to take the elementary reactions. You have to take the elementary reactions in that rate determining step, you have to say. Fine, that's good. Ankush, it cannot be more than 3 according to collision theories. I think you can understand. If it is more than 2 or 3, you have to take the elementary reactions, stepwise reactions. Fine, that's good. Let's go ahead. So, order of a reaction can be 0, 1, 2, 3 and even a kind of fractional also, right. So, we will discuss the order and molecularity and the differences, then you will understand the actual question. Once you complete your molecularity, you will understand. So, we will be talking about elementary or simple reactions and complex reactions. In that complex reactions, it is going to be more than 2 or 3, there you have to identify that. Fine. Now, let us say units of the rate constant. Units of the rate constant. In the units of rate constant, rate is equal to k, a power x and b power y. In that k, rate constant is equal to rate upon a power x and b power y. Rate, we have the concentration upon time, a power x and b power y, you have to take 1 by concentration to the power n, where n is equal to x plus y. So, this is the one formula you can assume to have. Yes, you can assume to have the unit for the rate constant, where n is the order of a reaction, where n is equal to order of a reaction. In this n value, you can see various for it is 0 order reaction, order is going to be 0. So, let us take the n value as 0, mole liter inverse upon second into 1 by mole liter inverse of power 0. So, anything power 0 is going to be 1, it is going to be mole liter inverse second inverse. So, the k value, k units, the order of the, you can see the rate unit is equal to rate constant for 0 order, the units for rate is equal to rate constant. That's a very important. Ankush Mahajan, right? Yes, it is. Now, for the first order reaction, n is equal to 1, so that it is going to mole liter inverse upon second into mole liter inverse power 1, so that you can strike this, So when you strike this now, you are going to get second inverse is the unit, K unit is going to be second inverse, right? And for the second order, n is equal to 2, you can say mole liter inverse upon second into 1 by mole liter inverse square, so that you can say mole inverse liter second inverse. Like that, you can use anything from this particular formula, right? This is a common formula, you can use it. Rahan Rajputra, fine. Ishita, Abhinav, Ayanaj. Okay, let us talk about integrated rate equations. When the reaction is started, as the reaction proceeds like this, so the change in the concentration initially is different from, in the middle is different from, at the mid or somewhere at the end. So the rate of a reaction is not uniform throughout it. So that what I need to do, sir, cross cut karna, yes, Rehan Rajputra, yes it is, yes it is. Now what I have to show, initial state to final state you have to integrate. So various integrated expressions are important. We will see in today's class, zero order ke देखना है, the first order को भी देखना है ना? So for the zero order, the rate of a reaction is proportional to the zeroth power of the concentration of the reactant. So if this is given as rate, so reactant gives rise to here, reactant gives rise to product, reactant gives rise to product, and the rate of the reaction is equal to K and reactant to the power 0. So what I mean to say, you can also say rate of the reaction is equal to dr by dt, dr by dt. Anything power 0 is equal to 1, am I right? Anything power is equal to 1, right? So that I just want to say from here, integration from 0 to t times it can be given, right? So that is given as, so rate of a reaction is going to be uniform throughout the time for the zero order reaction. Okay? And also you can say, consider this reaction, reactant gives rise to product and rate is equal to minus dr by dt is equal to k r naught. So I can say dr by dt is equal to k into 1. So this value is going to be 1. Anything to the power 0 is 1, am I right? So that you can say dr is equal to minus k dt, and this is going to be integrated from 0 to t time, so that you can say the integrated rate expression is going to be r is equal to minus kt plus I is your integration constant. In this integration constant, when t is equal to 0, the concentration of the reactant r is equal to r naught, unnecessary person. Okay, what is for no? What is for no? May I know the reason? Okay, right. So when you put this I value there, so you can say substituting the equation r naught is equal to minus k into 0 plus 1, so r naught is equal to 1. Put this r naught is equal to I, put this r naught value over here, put this r naught value over here. So you are going to get, substituting this value, r is equal to minus kt plus r naught. So this particular expression gives you graphical, okay, no problem beta, no problem, follow the class, graphical interpretations from the basic mathematics, it's okay, it's okay. So that you can also say k can be written as r naught minus r upon t. You can also better you write like this, k is equal to r naught minus r upon t. You can also say in some books it is written as k is equal to a naught at upon t. So what is a naught? Initial concentration, and at concentration at that time. Is that fine? Is that fine? So let's talk about, you can say it is R naught minus R upon T, can also be written as minus Ct minus C naught upon T, where C naught is the initial concentration of the reactant and Ct is the concentration of the reactant at any time after T after the reaction is started. So this can give you some graphical interpretations, let us say. So this particular expression, what is this expression? K is equal to minus C naught Ct upon T. This above expression is clear. If you plot Ct as a function of time T, then will be a straight line with a negative slope K, and Y is the intercept. You can say from this C concentration and time T, and you are going to get a straight line with a negative slope. From this slope you can calculate the concentrations as well. Okay, so the nature of the graph can be predicted based on the particular graph that is given. There are 6 graphs that are given in the NCERT textbook. These graphs you have to study. Based on the graph directly you will be getting a question from NEET examination. Ready for that? Ready for that, my dear students? Right. And Rehan Rajputra, Ankush Mahajan. Okay, let us talk with more stuff here. Now let's see here, and half-life. What is the half-life? The time required to consume the half of the reactant is called half-life. So you can say K is equal to, for zero order, K is equal to Ct minus C naught upon T. When putting the Ct value of 0.5 C naught, so the time required for this is going to be T becomes T naught, T half is going to C naught by 2K. So in some books it is written as T half is equal to A naught by 2K. So A naught or C naught doesn't matter, R naught by 2K. So I just want to say T 1 by 2 for the zero order is directly proportional to A naught. If you talk about the concentration of A and the T naught, as the initial concentration is increased, half-life also proportionately increased. This is the nature of for the zero order. So simply you will be given okay, Indraja, A naught is not 1, A naught become A naught by 2. Indraja, A naught become A naught by 2. Fine. So you will be given a question where you are asked to find a graph is given, what it could be the order for this reaction, or otherwise the order of a reaction will be given in the question. You have to check the appropriate graph in the options, right? So Abhinandan Mukherjee, for a first order reaction T half is equal to 0.693 by K, then means half life is independent on initial concentration. आप जो बोल रहे हैं ये सही बात है बेटा अभिनंदन मुखर्जी, that's correct. So here for zero order half life is dependent on the initial concentration, whereas for the first order half life is independent on the initial concentration. Anyways, I am going to explain that also, as Abhinandan Mukherjee is given a doubt over there. For the first order, T half is equal to 0.693 by K, that's it. So if you talk about this concentration of A and the T half is going to be T half as concentration of A, you can say here, right? You can say it is a T half and a concentration of A. T half do not change as concentration of A is continuously increased. Is that fine? Is that fine better? That's Ishita. Where did you go? Actually, you kept quiet in the chart box. Are you really not charting, or you stopped charting, or is there any technical glitch in today's class? So every day in the class, the chart is going to be rolled up like anything with a lot of fiery emojis. And आज charting में कुछ नहीं आ रहे, so मैं ये सोचना बता रहा हूँ. Okay, are you continuously charting or just kept quiet? So go ahead with the charting so that I can understand is there any technical glitch or not, because that connection is showing excellent for me there. Now talking about zero order reaction, examples of zero order reactions. Indraja, right. So whenever I want to say here, do we have to memorize the every example for in each order? No. But for zero order I can say any compound decomposed on the surface of a substance is going to be zero order. And the decomposition of gaseous ammonia on a hot platinum surface at high pressure is a zero order. And also you can say thermal decomposition of Hi on a gold surface, Hi, thermal decomposition, H2 plus I2. All photochemical reactions. Okay, don't be calm today, Indraja and Ishita. And also I just want to say photochemical reactions are zero order reactions, mind it. Okay, thermal decomposition reactions are zero order, you just mind it. Okay, so without any delay we will go into the first order. First order. So if you get any question, maximum of the first order questions only it will come. Maximum of first order questions, right? So the rate of reaction is proportional to the first power of the concentration of the reactant is called as first order reactions. So you can say here this is the first order, as the rate and the time it is going to be decreased like this. Rate of first order reaction exhibit exponential decay as time proceeds. This particular point is noteworthy point, my dear students. H2 plus Cl2 gives rise to 2HCl. Yes, it is. Yes, it is. In the presence of light. That takes place in the presence of light. Indraja. So here the rate integration we just see. Rate is directly rate reactant gives rise to product. Rate is going to be minus dr by dt is equal to k r. So when you talk about or dr by r is equal to k dt, so you can just go from the integration 0 to t time, so that you are going to get integrated. Integration of this equation is going to give rise ln r is equal to minus kt plus I. I is an integration constant, Rehan. I is an integration constant. So again, how do I get I value? When t is equal to 0 time and r is the equal to r naught, or in some books it is given as a and in books it is given as a naught, doesn't matter, where r is the initial concentration of the reactant, and therefore equation you just want to write ln r naught is equal to minus k into 0 plus 1. By taking this, ln r naught is equal to I. Put that I in the previous equation that we have seen, and substituting the value of I in the equation, ln r is equal to minus kt plus ln r naught, है ना, ln r naught. So that you can manipulate this one, you can manipulate this one, ln r is equal to minus kt plus ln r naught. From this you can draw a couple of graphs. I am going to explain that couple of graphs. Stay tuned, my dear students. You can say rearranging the equation, ln r upon r naught is equal to minus kt, है ना, minus kt. So that you can say k is equal to 1 by t ln r naught by r. This is what you call it as first order rate expression, integrated first order rate expression. You can also say at the time t1 from the equation 2, you can say this ln R1 is equal to minus KT1 plus ln R0. At time T2, ln R2 is equal to minus KT2. K do not change. Indraja, K do not change. He says Sri Chaitanya fires. Okay, that is always fires. And minus KT2 plus ln R0. So, where R1 is the reactant concentration at time T1, R2 is the reactant concentration at time T2. So, you just take these two values, subtract it, ln R1 minus ln R2 is equal to minus KT1 minus KT2. So, ln R1 log A minus log B is equal to log A by B is equal to K T2 minus T1. So, that K is equal to 1 by T2 minus T1. So, K is equal to 1 by T2 minus T1 ln R1 by R2, right. So, that you can say comparing the equation, this one you can draw a graph I said. So, y it is equal to y is equal to mx plus c. This equation of straight line को बराबर देख रहे हैं ना? Yes, exactly Rajan. And if we plot ln r versus t, we are going to get a straight line with a slope of minus k and intercept is equal to ln r naught, that I want to show you. And from this particular graph you can draw the k value, you can calculate from the slope. Mind it, this is a very very important graph. This graph हिसाब से a question आप सीधा निकाल सकते हैं, नहीं निकाल सकते. इशिता, this graph एक बार everybody make a note of it जल्दी. Let's see. Noted, Rehan Rajputra, it's very important. And first order reaction rate K is equal to 1 by T ln R naught by R can also be written as the form like you see K is equal to 2.303 log R naught by R, or log R naught by R is equal to KT by 2.303. From there you can say log R naught by R upon time, you are going to get a straight line passes through origin and slope is going to be K by 2.303. And somehow I just want to show you this one. In various books the same equation is given as K is equal to 2.303 by T log A naught by AT, initial concentration A naught and concentration at time T. In some books it is written as K is equal to 2.303 by T log A by A minus X. So, let initial concentration is A and during a reaction at time T, X amount is consumed, so that A minus X is the amount of the substance that is left, that is called A minus X. In some books in different written as A by XYZ, right? So, you don't worry, so you studied in one way in one book, sir is teaching in a different way. No, everything is same. Everything is same. Are you with me? Right. So, let us see some more details about the first order. So many examples are there. First example, hydrogenation of ethane is a first order. Yes, Abhinandan Mukherjee. It is going to be like this, and also decomposition of N2O5. N2O5 decomposes, and also decomposition of hydrogen peroxide. H2O2 gives rise H2O plus half O2. Yes, and Half-life for the first order. What is the half-life? The amount of time required to consume half of the concentration initially taken. When 2k is equal to 2.303 upon time log r naught by r. When t is equal to t half, r is equal to r naught by 2. So k is equal to 2.303 upon t half log r naught by r naught by 2. So when you take t half that side, k will come like this. So t half is equal to 2.303, that is going to be r naught cancel, and 1 by 2 comes to be, top is going to be log 2. Yes, Indraja, it is correct. So log 2 is equal to 0.3020. This value is going to be 0.3. Okay, when you is going for the 2.303 upon k into 0.3 is going to be t half 0.693 by k. Abhinandan Mukherjee, that's what you want to say in the previous discussion with you, between you and me. So that t half for the first order reaction is independent on initial concentration. I just want to say T half and the concentration of A, it is going to be a straight line parallel to x-axis. Fine, straight line parallel to x-axis. Okay, that's very, very important. Very important. Yeah, I started everything from the scratch. It is. I started everything from the scratch. है ना? Any doubt? Indraja, you can ask any doubt. Okay. So let's talk about features of the first order reactions. Features. What are the salient features of the first order reaction? Let's see. So first of all, a first order reaction must follow from the rate law for all times of instants. This means if we are given value of C naught, the value of x at different times of instant, I mean to C naught minus x as a value of the reactant after t, time t, the value of the k can be calculated from the differential time instantaneously. Yes, and also you can say the time of half reaction for the first order reaction is independent on initial concentrations. And also you can say the concentration of the reactants in a first order reaction decreases exponentially with time. That's what I want to say. That is a graph. So Ct is equal to C naught exponent minus Kt. That is the exponential form of the first order rate of the reaction. Okay, exponential form. You can also say, note the plot of log K Ct versus time is linear. It is important to note that equation of this straight line is the form of y is equal to mx plus c. You can see this graph here, log c and t is going to be a straight line with a negative slope. Slope is going to be minus k upon 2.303 minus k. Okay? Yes, it is. Correct. We are going to complete the syllabus on par with the plan. The plan is there and you can fill the Google form that is given there, and you can see. In the Telegram channel also, Indraja, you will be having all session updates and session notes based on that. Is that fine? We are going to finish the syllabus on par. So far we completed many things in the 11th standard: atomic structure, periodic classification, chemical bonding, S block, hydrogen, thermodynamics, and in the grade 12 haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, and we completed solutions and colligative properties, and chemical kinetics we are doing. So electrochemistry we already completed, and you can see all the missed sessions on recordings, and if required according to the request by the students, I am going to repeat certain more concepts. Is that fine? GOC is your favorite chapter. Oh wow, GOC last Saturday we completed we done almost 50 to 60 questions, remember? Abhinandan Mukherjee. Yes, that is the way. That is the way you can do it. Ishita, fine, right. Okay, let's go ahead with that. Okay. So why not, when you have kind of discussions, some kind of requirements, you can ask in the chat box or you can put in the comment box so that we can have a discussion based on that. Every academic comment is going to be honored. Are you ready? Ready, beta? Yes. Now let us go some more details about that. And log Ct is equal to minus k upon 2.303 t plus log 10 C naught is the equation of straight line here. Note that the slope of the line is going to be minus k by 2.303 and y is the intercept where initial concentration is given. है ना? Now rate constant of a first order reaction can also be calculated by measuring the concentration of the reactant at 2 time instants if the initial concentration is not known. If initial concentration is known, it's not a matter. If initial is not given, you can take any 2 instants and in between that integrated expression can also be applied. If C1 and C2 are the reactants concentration at 2 time instances, one is T1, another one is T2, and then we can have 2.303 log C0 upon C1 is equal to KT1 and 2.303 log C0 upon C2 is equal to KT2. है ना? And you can take these two expressions and subtracting these two, what we are going to get? 2.303 log C1 upon C2 K T2 minus T1. So this particular expression that I have given as a NEET examination direct question, you can get it. That's very, very important. That's very, very important. You're all with us. You're all with us. Very good. And we are doing the best out of this. If zero concentration, zero time is given, and A0 is given. If A0 is missing, use this formula so that you can get the K value. You can get the K value. And also, so K can be evaluated from this. So this is how you are going to get a NEET examination questions, my dear students. Okay. And also after first half-life, Ct is equal to C0 by 2. Second half-life, Ct is equal to C0 by 2 square. And you can say Ct by C0 is equal to 1 by 2. Okay. And Ct upon C0 is equal to 1 by 2 square. It is said that 2 square, no? Okay. It is said that 2 square, no? You can say it is 2 square. And after nth half-life, Ct upon C0 is equal to 1 by 2 n, where n is the number of half-lives. So I just want to say, let us say a substance 100 grams is taken. Let its half-life is 5 minutes. So after 5 minutes, it is going to be 50 grams. So after 5 minutes, it is going to be 25 grams. After 5 minutes, it is going to be 12.5 grams. After 5 minutes, you see how the half-life is analyzed. After 5 minutes, इससे आधा होना चाहिए 6.25 or 3 point something will come. So you can say here, you can check the time, from here to here it is 5 minutes, from here to here it is 10 minutes, from here to here it is 15 minutes, from here to here it is 20 minutes. Like that, for here to here it is 25 minutes. How much time it takes? Bipin, good afternoon. How much time it takes to complete 0? Infinite. It takes infinite time. So, first order reaction never goes till completion. Understand? Infinite time it will take. And you will be getting a question from the NEET examination, how much is going to be left at a nth time. So you use this and you are going to get the best. Any doubt? Bipin, you came late. Okay, let's see some more important salient features of this first law. The differential rate law can be integrated for nth order as well. For the nth order reaction, it is written as 1 upon n minus 1 of 1 upon Ct to the power n minus 1 minus 1 upon C naught power n minus 1 is equal to Kt. This can be applied for nth order reaction. We have seen the in detailed picture about 0 order and the first order. This is all about the nth order. Okay, and the above equation is integrated rate for the nth order, and also from the expression it is clear that T half is equal to C naught power n minus 1. This is also very important. Okay, this is very important one, and you just all make a cheat sheet for every formula for the total physical chemistry parts. Okay, I am going to make a formula sheet for this physical chemistry part. Just I did in the solutions on colligative properties one day, and you all had the formulas on the day, right? Remember in the last week. And also order of a reaction N can also be evaluated from the measuring T half. The reaction of different values of initial concentrations C naught of a reactant molecules. If C naught 1 and C naught 2 are the initial concentration of the reactant, T naught 1 and T naught 2 are the half-life of the respective reaction studies, and we are going to get T naught 1 by T naught 2 is equal to C naught 2 by C naught 1 to the power n minus 1. If you extend this, take the logarithms on the either sides, n order can be evaluated. It is going to be n is equal to 1 plus log to the base 10 of T naught 1 by T naught 2 upon log to the base 10 with C naught 2 by C naught 1. So this expression can be used to evaluate the n value. N is equal to order value for the half-life reaction. My dear students, hope you can understand this formula, right, Ishita? And we are going to discuss about the pseudo first order reaction. This pseudo first order reaction is the reaction, actually it is a second order reaction, but whenever one of the reactant concentration is taken in large excess, the reaction rate, the reaction order with that respective to that reactant is going to be 0 and behave like it's a first order reaction. That is what you call it as pseudo first order reaction. There are actually a bimolecular, order is going to be 2 and order becomes 1. So you can say ester hydrolysis, the rate is going to be K, ester concentration and water concentration in the presence of an acid, and if water is taken in a large excess, it is constant, so that rate is going to be 1. So this is called as false first order reaction. One more example we can give, it is for hydrolysis of sucrose it is also pseudo first order reaction. So my dear students, we are at the end of the session. Here I just want to say we discussed a lot of stuff in today's class. In this lot of stuff, what we had: total rate and instantaneous rate, average rate, and also we had discussion about the zero order integration rate and the first order integration rate. So, and we have seen half-lives and integrated and various graphs of first order, zero order, and t-half graphs and all. And at the end, my dear students, you all just go through the Infinity Learn study program, and we are going to launch a program that is starting from August 3rd. The first batch is going to be started. These are all the silent features that is given by the Infinity Learn, and also eminent faculties are going to take the course. And the last year, these are the students as I want to propose. Yes, Abhinandan Mukherjee, I will attend your doubt. Yes, there is a huge improvement in their scores and their marks, and I request you, please go through the course, and it is very cheap. Nobody is going to offer that rate, and use Suresh 50 is a coupon code, and इससे आपका 20% discount भी मिलेगा. And Abhinandan Mukherjee is asking a doubt: pseudo first order is a type of zero order? No, pseudo first order is actually a second order reaction. Behave like a first order reaction, Abhinandan. Is that okay? Suresh, fine. Very good. It's Bipin, Ishita. We are at the end of the session. Thank you very much. Thank you, and we are going to see some more details in tomorrow's class. Thank you, and stay tuned and study well and raise up with Infinity Learn. Signing off, Suresh, Faculty of Chemistry. God bless you all. Bye-bye.